Hello and welcome. So let's talk about integers and negative numbers in general. So we all know the number line, right? In the middle we got 0, 1, 2, 3, 4, etc. So we go to the right. So we go to the left, we got our negative numbers. Negative 1, negative 2, negative 3, negative 4, etc. to the left. And there's numbers in between those, but the integers themselves is the name for the set of numbers that are just the whole numbers and their negatives, and 0 as well. 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. Integers and any number in general has two major properties to them. They have the sign and size. Sign is just whether it's positive or negative. And by the way, 0 is neither positive or negative. It's kind of it does its own thing. And size. And that's how far away the number is from 0. Sometimes we call this the magnitude or absolute value. And we denote this by using these vertical bars, putting a number in between those vertical bars. So for example, the size or absolute value of negative 4 is 4. The size of positive 4 is also 4. So what absolute value does is just strips the negative off. It's intuitively the distance from 0. Negative 4 is 4 away from 0, but also 4 is 4 away from 0. It's a positive distance. By the way, the absolute value of 0 is 0. And this can be done with any number. The absolute value of negative 2/3, its sign of 2/3 of negative 2/3 is negative. Its magnitude is, well, 2/3. The absolute value of 2.7 is 2.7. And that's pretty much it. So where do we use these numbers? Where do we use negative numbers? Where do they pop up? One of the obvious places I can think of, and you might have thought of this, is how we represent elevation. If you look up Death Valley, it has an elevation of negative 282 feet. What does that negative mean? Well, that negative represents it's negative 282 feet. It's 282 feet below sea level. The 0 in this case is sea level itself. If it was positive, like if it was above sea level, it'd be positive. But so this negative here encodes whether we're above or below a certain elevation, that elevation being sea level. You might think of how we represent whether we're in debt or not, or if we're checking credit or debit to our checking account, say. So positive means we get credit, we're getting paid money into an account. Negative would be a debit. Third thing which comes up a lot, at least it's going to come up quite a bit in this class, is how we represent change. If we have something that's worth $24 and it increases in value to $30, then we can represent that change by subtracting 30 minus 24 by a positive number, $6. A positive $6 increase in value. If we went the other way, $30 decreases to $24. Now the change, the absolute value of the change is still $6, but if we make sure we do it in the right order, 24 minus 30, our final value, minus our initial value, then we'll be guaranteed to get the right sign, which will encode, if it's negative, it will encode in itself that it's a decrease. We don't have to remember it's a decrease. We can just look at the sign of it. It's like, oh, that's a drop in price because it's negative. If it's positive, encoded in it is an increase. Whenever we're looking to calculate the amount of change, that's final minus initial. So what if we want to compare two numbers that might be positive or negative? For example, -7 and -4. Which one of these is bigger? Well, we use the symbols less than and greater than to represent which one is bigger, or maybe we might have equal signs in here too, less than or equal, or greater than or equal. But I tend to, instead of calling these less than or greater than, I often, if I'm saying it or if I'm in my head, I might think of it as this less than is to the left of on the number line. Means less than. And this symbol, which is greater than, is to the right of. Greater than. And that will help me visualize what's going on here. If I want to compare -7 and -4, -7 is less than -4 because it's left of -4 on the number line, right? Here's 0, here's -4, 5, 6, 7. -7 is over here. Now, if we were looking at their absolute values, yeah, -7 is bigger in size than -4, right? Because 7 is bigger than 4. Our traditional way of thinking of greater than and less than usually deals with positive numbers. But when we start throwing negative numbers in there, you have to think of it as to the left of or to the right of. This can be done with fractions as well. So if we want to compare, say, -2/3 to -5/8, you can do this just like you compare fractions in general. You can do this cross multiplication, keeping the numerators where they're at. Keep -2 and -5 on the respective sides. So -2 times 8 on the left and -5 times 3 on the right. We get -16 on the left, -15 on the right. -16 is less than -15 on the number line, right? So that means our original fraction is also less than. So lastly, I want to talk about some operations. Operations with positive and negative numbers. Now, multiplication division is pretty straightforward. If you got obviously a positive times or dividing another positive, that's positive. If it's a positive times a negative, it's negative, or negative times positive is negative, and two negatives multiply to positive. So this is whether this is times or divide. We got a positive divided by a positive. It's positive. Positive negative divided by a negative, or negative divided by positive, that's negative. Or negative divided by negative is positive. And that's because division is the same as multiplication, right? Dividing by something is the same as multiplying by the reciprocal. So the rules for multiplication and division are the same. Addition and subtraction are a different deal. It depends upon which one's bigger. Which one's bigger? So we'll start with addition first. Subtraction is similar, but we'll usually change our subtractions to additions. So if you have, say, for example, 3 plus 5, that's good, that's 8, right? If they're the same sign, -3 plus -5, we'll think of them as being on the number line, and they're going in the same direction, right? So just like 3 and 5 add to each other to get 8, -3 and -5 add to each other to get -8. So in some sense, you're starting at -3, and we're going to continue going 5 to the left. Negative means we're going to the left, right? If they're the same sign, then you just add their two absolute values, their sizes, and just keep the same sign. Problem arises when they're different signs. -3 plus 5 or 3 plus -5. It matters which one is bigger here. kind of think of these two numbers as having a little tug of war. In this case, you've got -3, and you're going to add 5 to it, which means you're going to go 5 in this direction. 3, 2, 1, 0. So you go 1, 2, 3, 4, 5, up to +2. So this is a positive number, +2. You can think of them as a tug of war because this ends up being just 5 minus 3. Just take 5 minus 3 and it's 2. And the sign of your answer is the number that's bigger. 5 is bigger, so it's positive, so our answer is 2. The thing here with 3 plus -5 here is it's still a subtraction problem, except we're starting at +3 and going to the left by 5, right? Still a subtraction problem though. Still 5 minus 3 is 2. Because they're opposite signs. They're pulling in different directions. But our sign of our answer is whichever one wins the tug of war, which is our -5. And so our answer is -2. That's generally how you do it. If they're the same sign, if you're adding, this is all addition, remember, we haven't talked about subtraction yet. If we're adding the same sign, then you just add their sizes and keep whatever sign they are. If they're different signs, it becomes a subtraction problem, really. Subtract the bigger sized one minus the smaller sized one, and then the sign of your answer is the sign of whoever won the tug of war, the bigger number, bigger in absolute value. So what about subtraction? The way I think about subtraction, 5 minus 3, that's 2, right? You can think of it as starting at 5 and going to the left by 3. But it turns out adding 5 to -3, or adding -3 to 5, is the same thing. Still 5 plus -3. They're opposite signs when you're adding, so it becomes a subtraction problem. These two are the same. So subtracting is the same as adding the opposite. And this becomes particularly useful if we're subtracting a negative number. 7 minus a -3. I'll put a negative in parentheses just so it's not too confusing where you have two minuses next to each other. But what happens when you subtract a negative, a minus, if you will, becomes adding its opposite. So those two minuses basically just cancel each other out. This is just 10. So 7 minus -3 is just 7 plus 3 in disguise. So pretty much if you see a string of addition subtraction, I'll often change all my subtractions to adding a negatives. So 13 minus 4 plus 7 minus 10 minus a -3, say, plus 6. First thing I'm going to do, just because some of these are positive, some of these are negative, some of them are positives in disguise, especially if I ever see a minus, a negative, I'm going to switch that. So I'll immediately change that to adding a negative, and I might either in my head or physically, explicitly change these. Once you have this, now we can take stock of what we have. We have 1, 2, 3, 4 numbers that are all positive. So you might just add those together first, and then we could add the negative numbers together, and then we can just do one subtraction at the end. So 13 plus 7 is 20. 20 plus 3 plus 6 is 29. And we've got -4 plus -10, that's -14. So we're going to subtract 14. See how I switched it? Technically it's 29 plus a -14. But I kind of just switched it in my head, 29 minus 14. 29 minus 14, the bigger number is 29, so our answer is going to be positive. So it looks like we got 15 here. That's the answer. That's pretty much it. Obviously, I'm doing all of these with integers, but you can do all these same rules apply for adding, subtracting any positive negative numbers. So that's enough for now. See you next time.